Hi, everybody. Welcome back. Root Beer here. We're going to be finishing off the 2007 Friar Contest. In this video, we're going to be looking at question number 4, grade 9 level contest, if you haven't been watching all along. And if you have been watching all along, welcome back. We're about to finish off the paper. So let's take a look at question number 4. Alright. So it's a 3-part question, and it looks like going to be some geometry and perhaps some 3-dimensional geometry. I see the outline of a pyramid. Okay, so A part. In the diagram, triangle XYZ is right-angled at X, with YX equals 60 and XZ equal 80. Okay, so here we have the lengths labeled. W is the point on YZ, so that YX is perpendicular, WX is perpendicular to YZ. Determine the length of WZ. Explain how you obtained your answer. I think they've said explain how you obtained your answer for every question on this contest. Have they done that in past years? I don't know. It's neither here nor there. Alright, on with the question. So we need to determine the length WZ. Well, it's probably best to give it a name, something like X or Y or maybe W or V, something like that. So let's draw ourselves a picture. Doesn't have to be super accurate, although I find when I'm on contests, a little help doing the right-angled triangles is to take a scrap piece of paper and use the corner. That definitely gets me a right angle. So we have Z, we have W, we have Y, and I believe this was 60 and this was 80. Right angles here and a right angle here. Okay. So let's just double check that I got the values right. 60 goes with YX and 80 goes with XZ. Okay. So let's let WZ equal, WZ. I don't know why I keep saying Y instead of W. We'll let that be V. So X, Y, and Z is a Pythagorean triangle. It's a right angle triangle. So by the Pythagorean theorem, 60 squared plus 80 squared is going to be YZ squared. So we get out our calculators, 60 squared plus 80 squared is going to give us 10,000. So that means that 100 is going to be YZ. We just square root both sides. So that tells me that YW is going to be 100 minus V. Okay. And we have this common perpendicular, call it H. So I'll let H be XW. Well then, 100 minus V squared plus H squared is 60 squared, which we just computed a second ago by our calculator. That's 3,600. And we could expand this out, but we'll leave it for a moment. V squared plus H squared equals 80 squared, and that's 6,400. So we have this common H term here. So one thing we could do is we could take the top equation and subtract off the bottom equation. That'll just leave us with something in terms of V and some numbers. So 100 minus V squared These two guys cancel each other out. That's going to be 3,600 minus 6,400. Probably should have done this the other way around if we'd been thinking ahead, but that's okay. Still valid. So that's negative 2,800. So now let's expand this out. So 100 minus v squared, so that's going to be 100 squared minus 2 times 100v plus v squared minus v squared is negative 2,800. Okay. Well, fortunately for us, these v squareds are going to cancel each other out. So we're going to be left with 10,000. We'll bring the 2,800 over to the one side, and we'll bring this negative 200v over to the other side. That's positive 200v. So 2,800 plus 10,000. It's going to be 12,800. Divide that by 200, and that should be v. So v is going to be equal to, is going to be equal to 64. So we get a length of 64, and that would make YW 36. And we could probably use those and the 80 and the 60 to independently verify this by getting a common value of h. There's two ways to compute h. 60 squared minus 36 squared should be h squared, and 80 squared minus 64 squared should also be h squared. So we could do a little double check. So we get 2304, which frankly I don't remember the square root of that. 48 squared. And then double check 48 times 48 plus 36 times 36. That should be 60 squared, and it is. So we can just do little double checks by making sure that we can complete everything with that value of h in there. But if you don't have time for it, you don't have time for it. That's okay. We got the length of 64, so we move on. Okay. B part. 5 points, A, B, C, D, and O, lie on a flat field. A is directly north of O, B is directly west of O, C is directly south of O, and D is directly east of O. Okay, so just as they've shown here, if we imagine this is like the y-axis and this is the x-axis, O is the origin, A, B, C, and D lie on the axes with different positive and negative values. Okay. The distance between C and D, which we don't have marked on our diagram, is 140 meters. A hot air balloon is positioned in the air at H, above O. So he's directly above O, but he's going to have some sort of positive Z coordinates. That's okay. The balloon is held in place by 4 ropes, HA, HB, HC, and HD. Rope HC, so this one right here, connecting up with C, is 150 meters. Rope HD is 130 meters. Determine how high the balloon is above the field. That is, determine the length of OH. And as usual, explain how you got your answer. So let's draw ourselves a little copy of the picture in our solution booklet here. D, A, C, B, we have O in here, we have H up here, okay, and we want this length right here. In fact, let's give him a special color. I'm in the mood for the light blue. Okay. So we know this length here, C to D, 140 meters. We know this length here is 130 meters. And we know over here we get 150 meters. And we want this height, which is h, let's say. So let's let that be h meters. Okay. Well, I notice in here I've got a lot of right angle triangles. I mean, I also have triangles for ADO and things like that. Those are right angle triangles as well. But I think all the information we're given involves C and D, so I don't think A and B are necessary. They'll probably be in part of the next question, maybe. Or that they're just to look good and give us a sense of symmetry. And our last triangle is DOH. And actually this one should be COH, because it's right angled at O. We try and keep the right angle in the middle, usually. Okay. So let's give names here. Let's let that be X and that be Y. Let CO equal X and DO equal Y. Well, then X squared plus Y squared is going to be 140 squared. 140 squared is 19,600. Yeah, so X squared plus H squared. Remember, H is the one we want. So that's going to be 150 squared. 22,500. And Y squared plus H squared is going to be 130 squared. That's 16900. Okay. So notice that the h's that we want here are sort of cluttered up by these x's and y's squareds. But I know what x and y squared is altogether. So what if I were to add these two? I'll get two copies of h squared, and I'll get an x squared plus a y squared, which I can substitute in with this. So a big old plus sign, x squared plus y squared plus 2h squared is going to be 22500 plus 16900. So 39400. So 19600 plus 2h squared is 39400. So 2h squared is 39400 minus 19600. That's going to be 19800. That means h squared, we divide by 2. So we get 9900, so 9900. And we can take out a factor of 100 here. We get 30 square root 11. Yeah, that's the most exact form. We can leave that in. Square root 11 meters. It's always best to leave your answers in exact form rather than rounding them off with any sort of decimal. If we hadn't been able to factor out this 900, which gave us a 30 when we square rooted the whole thing, it would have been best just to leave it a square root of 9900. But they do ask you to get it in its most simple form, and taking out all possible squares from 9900 is really the best way to go. So that leaves us with 30 times root 11. But I imagine you probably wouldn't be penalized that much if you just left it as square root of 9900. Maybe you should at least take out the 9, but either way, that's C part. We figured out the length of OH, and that is what we were asked for. Determine the length of OH. Fantastic. Okay. C part. And this is the last part of the contest. So let's hope it's a good question. To reduce the total length of rope used, rope HC and rope HD are to be replaced by a single rope, HP, where P is a point on a straight line between C and D. The balloon remains at the same position H above O as in part B. Determine the greatest length of rope that can be saved. Okay, so beforehand we were using ropes CH and DH, and that was 150 meters and 130 meters, using up a total of 280 meters. So to maximize the amount of rope saved, we need to minimize the length of HP. And C part sort of explains why A and B are there, because in the real world you would need 3 different tether points to keep a hot air balloon in a fixed location. If we didn't have A and B, then this question would make no sense, because the hot air balloon would likely float and be over point B rather than point O. Alright, so we need to minimize the length of HP. So let's draw ourselves our picture again. We get A, B over here, C, H. Oh, and we know what this height's going to be now. And we did have these ones. 130 meters, 150 meters, 30 root 11 meters. We know this is 140 meters. And we know that we have a point P somewhere on here. Let's use the light blue again. So we have P somewhere on here. Let's say P is over here. So we want to minimize HP. Okay. So this setup, the CHDP, it's a single triangle, and it reminds me of part A of the question. Okay. Part A, great part A. It's not just talking about right-angled triangles to get us prepped for part B that has right-angled triangles. It also might be giving us a hint as to how to solve part C. I'll show you what I mean. So let's consider triangle HCD. So P will be somewhere along here. Let's say it's over here. Now let's drop another point Q down here so that Q is an altitude of the triangle coming from H. Because if you want shortest distance between a point and a line, you want the perpendicular, the altitude here. We'll call this Q. We know that this is 130, this is 150. We don't have a use yet for the 30 root 11 we figured out in the last part. Maybe we won't use it, but we probably will at some point. 140. So notice that no matter where P is, HQ and P are going to form a right angle triangle, and that HP will be the hypotenuse. So if we wanted to minimize HP, well, if P is a place other than Q, this triangle shows us HP is going to be longer than HQ, and HQ is definitely, Q is definitely on CD. So there's at least a smaller, a point that P could be that gives us a smaller length. So we have to have P and Q be at the exact same place. So this allows us to redraw our picture a little bit. And I realize the 130 side looks longer than the 150 side, but it's all illusion. No, it doesn't really matter. As long as the numbers are there and the picture makes sense to us, it can be as whacked out as we want. So we want to figure out the length HP and then figure out how much rope we've saved. Okay. So let's let this be V. This is going to be 140 minus V. And we get H. So very similar to part A. Well, we can get we have two right angle triangles here, so we have two formulas for H squared. 130 squared minus V squared, and 140 squared minus, 150 squared minus 140 minus V squared. Okay. So, once again, we can play a little subtraction game. 0 is 130 squared minus 150 squared. Once again, I should have thought ahead, because now I have negative numbers here. It doesn't really matter. Negative V squared, and then we're going to add on 140 minus V. So these two equations here come from the Pythagorean theorem, because we have right angle triangles here. If you wanted to, you could make a note of that. I say we've been using the Pythagorean theorem and the right angle triangles for the last two questions. At this point, it should be clear what I'm doing. To the marker, at least. But not necessarily clear to you guys. That might be why you're watching these videos, and that's why I mentioned that I'm getting these formulas from the right angle triangles here. So we can rearrange, bring this 5,600 over to the other side. It becomes positive. And we're left with expanding this out. 19600 minus 2 times 140 times V plus v squared. And that's minus v squared. Stick them over here. These cancel out. Okay. I actually should have left this over on the other side. That's okay. So 280v 19600 minus 5600. That's going to be 14,000. 280v, so v is going to be equal to 14,000 over 280. I'm guessing it's going to be something like 50, because we got the 14 and the 28 there. And what do you know, it is 50. So we know what v is, that's fine. We want to know what h is, and from that h, we want to be able to figure out the length of rope that we've saved. That's going to be 16900 minus 2500. And we get 120. I was about to say 1200, and that would have been very wrong. Okay. So this is the minimum length of rope we can have. We want to figure out the amount of rope saved. Well, how much rope did we have? We had 150 meters plus 130 meters. But we could reduce that down to 120 meters. So that's a difference of 160 meters. So the most rope we can save is 160 meters. That's how much rope we could save in total. So there were lots of little bits to this C part. Yeah, we had to draw our picture, set things up, and then we recognized, hey, that looks a little similar to the triangle we had in the first bit in part A. You probably could have done it another way. You probably could have said let OP define OP, and you get a right angle triangle here, and you'd probably get some sort of equation in P in terms of this line. So there's definitely a way to approach it with 3 dimensions, but that's okay. That might have taken a little bit more time, or it might be elegant. I'm not going to investigate it now. So we recognize that it's very similar to a 2-dimensional setup we had in part A. We showed that P has to be at this perpendicular. Either we would know that from general working with lines, or we could say, how is the HP, how is this different than the setup we had in part A with the perpendicular and the altitude? Either way, we know exactly where P needs to be. Gives us 2 Pythagorean triangles, and we're able to solve for exactly the value of HP. But we're not done there. We need to figure out the amount of rope saved, and that becomes a quick calculation at the end. So that concludes C part of 4. All in all, I would say that the 2007 Fryer was actually a very simple paper, very short. There wasn't really any very lengthy bits or any bits that it seemed unintuitive. I think it was a very well structured set of problems. The part A's led into the part B's, led into the part C's. Very nice, very well put together. So hats off to the 2007 Fryer team. Sincerely. And that concludes the paper. We're all done. So join me for a 2007 Galois or Hypatia, or maybe join me for the 2008 Fryer, or, you know, take a look on my channel, look for a bunch of other videos, and if you like what you see, if you like the math content I do, feel free to subscribe. And, yeah, that's about it. So I hope you guys have a wonderful day, and I'll see you next video.